So I saw this video from Airsoft Kex. It's an airsoft sentry gun being made by Red Wolf Airsoft. I thought it would be fun to try and make my own. I have some of the hardware components already done, and there's things that they do that I'm not doing, like the remote control. I just want mine to be autonomous only. Okay, so the basics for the Airsoft Sentry Turret is going to be a turntable, and then a gun, which is going to be hooked up to a relay. Now for the sensing, I'm going to have a sonar sensor. The sonar sensor is going to shoot out beams. No, they're not going to be green. They're going to be sound waves. And for testing purposes, I'm going to set it up to 100 centimeters is the engagement distance. That's a yard, or a meter, you know, whatever. Um, and when it is in its scanning mode and it has nothing detected within the 100 centimeters, the base will be lit up green. When it does have something in its sight, and I just messed up my color palette, it will light up red, and it will begin firing within like half a second. I'll have to program that in, because I do not currently have a relay for the gun. But I do have the turntable, I do have a gun, I do have a sonar sensor. I can do more hardware explanation, which I will probably do later in the video, once as I show off the motors. And from here I'll go on to code. Alright, so here is the code. I have two libraries currently imported. Pololu LED strip, that's for my lights at the bottom. It's a Radio Shack, I think 1 meter strip. It doesn't really work that well with what they provided, so I had to look up how to use them. And then I have maxbotics.h, which is for my sonar sensor. And then this is just setting up all of the LED strip things. That's how many LEDs I have. That is the pin it's on. And that's how many colors I want, which is the same as... Wait, what? Oh, that's color for each 3 LEDs, because the chip controls 3 LEDs each. The 4 is how many different colors I want. I only set up 3 of them for some reason. This is setting up the sensor. I'm doing an analog for the maxbotics sensor on analog 2. This notates analog, and this is a sensor type, which is, I think, extra large. I don't know what the XL means for them. This is how frequently it's going to check. This is the timer for checking. This is all the motor stuff. Stopped, obvious, forwards, obvious, motor timer. That's for checking if it should go in reverse or not, or start up again. And it's going to check every 5 seconds, whereas the sonar sensor will be checking every 100 milliseconds. Now, for the color, I did red, green, and blue, except with the library, I think it's slightly mixed up. I'll have to check. 12 and 9 is for my motor shield. 9 is the brake. 12 is direction. I start a serial, which I never use. And then I set my timers to millis, just to start them. I start up my scan, which is right there. This is my start scan. So for this, I say turn off brake, set it to forwards, and then write it at full speed. Set my Boolean forward to true, since it is going forward and it is not stopped. So stopped is equal to false. And then I set the LED strip to green, which is color 0. Okay, so that explains that. So green is this top, is the first bit. And then I write it to my LED strip. And then after, I check my ping timer, which I used to use a ping sensor, but it's now just a maxbotics sonar sensor, which is more reliable in my opinion. I increment the timer to check, and then I check my sonar. Now, for sonar, I just do a simple if statement. If it's less than 100 centimeters, less than or equal to 100 centimeters, which it outputs in centimeters by default, stop scanning. Now for the stop scan, I turn the brake on, I set the color to red, I write it, and then I say stopped is equal to true. And for the motor timer, I increment it if it is stopped, if it is not stopped, my bad. I reverse the scan. If it is stopped and the range is, and then I check the range again. If the range is greater than 100 centimeters, start the scan again. And for reversing the scan, which I never went over, I set it to green again just in case if it was stopped, which I shouldn't need to do. I'll take that out right now. If it's forwards, switch it to backwards. Low means backwards on the motor shield, and then change the Boolean. If it is going backwards, change it to forwards. Forwards is now true. And that's it for all of the... Was I even recording? Okay, so here is the current setup. I have a 12 volt 2 amp, or I believe it's 2 amps. It runs on 2 amps. Window motor. If you don't know what a window motor, it's a motor that makes your car windows go up and down. Yeah, creative name, right? I have my Maxbotics sonar sensor. I believe it is a 1320. Let me check. Yeah, it's a 1320. And then I have my Uno over there with the motor shield. This is my LED strip. And then I have my wall power supply off screen with the plug right next to the Arduino. Let me just move the motor closer so then you can see everything. And now I shall plug it in. See? It turns. Yep. And it reverses. So I'll let that do it a few times. Yeah. It's a pretty strong motor. I mean, you can see that it jerks. And then if I were to put my hand over that, it immediately stops. And it takes the motor check timer to restart it. I have yet to get a motor encoder to limit how far it goes. And I'll probably need to get one of those. But yeah, it works so far. Okay, so for the original plan, I'm going to have one turntable, and then my belt gear in the center. That's not really the center. And then I'm going to have a second belt gear in between the two belt gears. I'm going to have, obviously, a belt, but the motor is going to be running from the one over here to the one attached to the turntable. I mean, that's as simple as I can get it right now. I can change it later if I really need to.